Hello everybody, we're getting ready to do lesson 2.1 part 2 classwork today for Algebra 1 Math. And on your classwork sheet you got 22 points. Students, have that out ready to go, and you'll have 14 points to go into your notebook or your notebook guide. Part 2, find square roots and compare real numbers. And students, remember to put your name, date, period here on your phone, your tablet, your PC, your Droid, your iPhone, your iPad, your Chromebook. Let's go into page 1, which is a classwork page, irrational numbers. The square root of a whole number that is not a perfect square is an example of an irrational number. An irrational number, such as square root of 945, is 30.74085, which is a number that cannot be written as a quotient, or rather a quotient of two integers, that's for sure. The decimal form of an irrational number neither terminates nor repeats. So there you know for sure you got an irrational number. So real numbers, a set of real numbers is a set of all rational and irrational numbers as illustrated in the Venn diagram below. Every point on the real number line represents a real number. So every number line is a real number. So we're going to get into our Venn diagram here. Rationals, and then rational numbers would be 3/4, 0.75 would be a rational. Then negative 1/3 would be negative 0.333. This is repeating, so it is rational. So you have integers and you have whole numbers inside here. And then irrationals are numbers that don't repeat. Decimals, non-repeating decimals like square root of 2, negative square root of 14, and then pi, which is an irrational number, 3.14159, blah, blah, blah. It goes on and on. So you got 2 points here on page 3. So with that in mind, and we got page 4, this goes into your notebook, classifying numbers. So tell whether each of the following numbers is a real number, a rational number, an irrational number, an integer, or a whole number. So you got square root of 24, square root of 100, and then negative square root of 81. So here's our first three numbers here, 24, square root of 100, and then negative square root of 81, just like up here. So is this a real number, rational, irrational, integer, or a whole number? So yes, 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 real number. Rational number, no, square root of 24 is not rational. These are irrational number, yes, for square root of 24, no, no, for square root of 100, negative square root of 81, integer, no, yes, yes, and then whole number, no, yes, no. So there is your chart for these numbers there. So with that in mind, let's graph and order real numbers now. So order numbers from least to greatest, and here they are: 4/3, negative square root of 5, square root of 13, negative 2.5, and then square root of 9. Begin by graphing the numbers on a number line. So here they are, negative 2.5, and then right here is a negative square root of 5, which is negative 2.24, and then 4/3, square root of 9, square root of 13, which is 3.61. So read the numbers from left to right. Negative 2.5, negative square root of 5, 4/3, square root of 9, and then square root of 13. So those would be the numbers from least to greatest. So now let's try one. Tell whether each of the following numbers is a real number, a rational number, an irrational number, an integer, or a whole number. So we got negative 9/2, 5.20, square root of 7, 4.1, negative square root of 20. Then order the numbers from least to greatest. You can do that here. List your numbers here, and then put your headings up here for real, rational, irrational, integer, or whole number. And then do the same thing down here, students, for your independent practice. Here's your numbers here. Here's your number line. So for a guided practice up here, do our guided. So here's our set of numbers. So Number negative 9 over 2, 5.20 square root of 7, 4.1 negative square root of 20. Reals are all reals. Rationals, we have a no here for square root of 7. Irrationals, you have no, 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 yes for square root of 7, no, and then yes for negative square root of 20. We're calling that an irrational number. And then from least to greatest, and we're not done yet, number, integer, and whole number. So again, a negative 9 over 2. Integer, no, no, yes, no, 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 no. This one's a yes for an integer. 0 is an integer. And then a whole number. Are we calling 0 a whole number? Yes, we are. And then whole numbers up here, no, 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 and no. So there's your classification. And then from least to greatest, here they are in a number line, negative 9 over 2, negative square root of 20, which is real close there. 0, and then square root of 7, 4.1, 5.2. So from least to greatest, negative 9 over 2, negative square root of 20, 0, square root of 7, 4.1, and 5.2. So there they are from least to greatest. And so what about that in your notebook? Conditional statements. A conditional statement not in the if-then form can be written in that form. So we're going to get into if-thens now. Rewrite the conditional statement in if-then form. Then tell whether the statement is true or false. If it is false, give a counterexample. So for this one, all repeating decimals are irrational numbers. And then this is yours down here, students. Let's do our guided up here. All repeating decimals are irrational numbers. Let's write this in if-then form. So to write that in if-then, then tell whether the statement is true or false. So we're going to write this in if-then. So given all repeating decimals are irrational numbers, if-then form. If a number is a repeating decimal, then it is an irrational number. The statement is false. That is categorically false. And so that does not work. So a sample answer will be 0.333 is a repeating decimal and can be written as 1 over 3. So it is a rational number. And that's your lesson for today. Animated PowerPoint math video at AOL.com for questions or course materials. Thank you very much.